So we're now going to be talking about something called the MathServices app case study. And this particular case study will demonstrate how to use various Java concurrency frameworks. In fact, we use 3 of them, using Spring WebMVC to perform a pair of math services, primality checking and greatest common divisor checking, in parallel. And as usual, you can find this code in my GitHub repository, in the EX3 project, in the WebMVC folder, in my live lessons GitHub repository. So we're basically showing how you can use Spring WebMVC to send and receive GET requests synchronously, because that's what Spring WebMVC does, to and from clients that are running in parallel, and there'll also be multiple microservices. And the goal of this is to show how you can do multiple microservices. We're going to be applying 3 Java concurrency models. In this case study, we'll be doing Java parallel streams. We'll be doing Java structured concurrency with the structured task scope approach. And then finally, we'll also be using Java structured concurrency with the executors approach, using the new virtual thread per task executor. The client will send requests in parallel using Java structured concurrency, the Java task scope model. So it's going to blast out a bunch of requests that will run concurrently. We'll see how that causes some challenges that we'll have to overcome. And there are 2 different microservices this time. This is what differs from our previous examples where we only had 1 microservice. And they will receive these requests in parallel and they receive them in bulk and process them in parallel using Java structured concurrency with the thread per task executor, as well as Java parallel streams. So the example is organized in a couple of different modules, and each module has a couple of different packages. And this all occurs in 1 project. So it uses a neat feature of IntelliJ where you can have multiple modules sharing a project. And it's got a client side and a server side. The server side has a microservices package that has all the entry points for the various controllers. We've got a pair of controllers, one for the GCD app and one for the primality app. And it's also got the microservice entry points, which are the apps themselves, applications themselves. And of course, there's also a pair of services that actually do the dirty work to implement everything. And this, again, will showcase the couple different concurrency models. As usual, there's a common package that contains a bunch of project-specific helper classes that are used both by the client and the server. There's some limitations with sharing of code between modules in a Spring project, so we have to make some copies, but it's the same code in both the client and the server. We've also got a utils package, which contains reusable helper classes that I apply in almost all the examples. There's a future utils class that we've looked at before that you're using in your programming assignment. There's a math utils class that has the GCD and prime checking methods in there. And then finally, there's a resources folder that defines various application properties that are important. In this particular case, it's the names of the microservices as well as the port numbers for those microservices. And we'll take a look at that a little bit later. We move those out of the code and into the resources file so it can be configured more flexibly. The client also has a number of pieces to it. There's a MathServices driver, which is kind of the test driver that causes the client to send and receive requests and responses to and from the various microservices running on the server, processes and displays the results. And this uses the structured task scope Java concurrency model. There's a client package that has some classes that provide proxies for the various microservices, as well as also providing sort of a way to consolidate the various proxies together so you can call them in a nice, clean, and generic way. There's also another utils package that has these reusable utilities, like the web utils package we've been using in the assignments and other examples, and random utils. And then finally, there's also a resources package, which defines some application properties, basically to disable logging when you don't want to have your screen overrun with lots of logging messages. So you can turn those on and off easily. And once again, we put that in the resources portion so we can change it without having to modify the code or recompile the code. Now, we're going to briefly talk about the pros and cons of this particular approach. And I want to be able to compare and contrast this with what we've covered before. So all the examples we've looked at so far related to Spring WebMVC have all had a single microservice, which allowed us to have a single test. So we had a single test that was a Spring Boot test, and it knew how to start up the single microservice. And if you recall what we did before, we'd often pass along a little integer tag that went with every request And that would be used to then select which implementation we wanted to have called in the microservice itself. So we're going to talk about the benefits of this new approach relative to the other way we did before. So one of the nice things about this approach is that each microservice runs in its own process and potentially its own computer in a data center or a cloud environment. On the tests I'm running here, of course, it's just running on my laptop, but it would be easy enough to do deployment in some other context where we could have these things running in different computers. And the nice thing about this, by splitting things into separate processes, we can improve system scalability because they can run on different computers. And we can also potentially improve system reliability by allowing things to have backups and failovers and load balancing and all this kind of good stuff that could be added, which we'll talk about later. Of course, not everything's rainbows and unicorns. So one of the downsides is the clients have to be explicitly programmed to connect with and communicate with each of these microservices explicitly. Now, this is a limitation of this example. The next example we're going to look at next time will remove this limitation by applying something called an API gateway pattern and the very cool Eureka Discovery service. But for now, we aren't going to cover those more advanced topics. We're just going to have two microservices, and that requires the client to know how to talk to each of them. And that approach, without additional help, can complicate configuration and deployment and testing and security. So it requires the client to know about all the various microservices. This direct client to microservice mapping kind of may expose some things that you don't necessarily want to have exposed. And it also complicates our testing because we no longer are able to use the Spring Boot test with a single program that automatically starts up the microservices. We can start at one microservice at a time, but I have not been able to figure out how to do multiple microservices started automatically with a Spring Boot test. So if you know how to do that, let me know. But for now, we're kind of limited in that. So this is just a quick synopsis of what's good about this approach, what's the limitations, and then not surprisingly, in future examples, we will overcome these limitations by applying more advanced features of Spring and doing modern web programming. So that's the end of the overview of this particular app case study.